The question of like, how does Newton's method get close enough to the root that you know what an exact root is, but not get close enough that some of your answers are still like 9.999? That and the thought of, somebody asked me this and it's annoyed me for weeks. Does Mike Wazowski blink or wink?
Oh my goodness, yes, I know that one. I would definitively say he blinks because winking implies that one eye is left open.
Are you sure?
Yes, I'm sure.
I thought it was just the closing of one eye. That is.
What are you blinking about?
The question was, does Mike Wazowski blink or wink?
You know the guy from Monster Inc. with one eye?
I said that to my sister and my mom the other day, and they're both mad at me that I said that.
Okay, what is actually are we doing?
How are you?
What is what? What are we doing?
Tired.
Yep. I guess.
Oh, June's preparing for your test.
I already brought
Everyone
everything.
probably didn't like an R at that.
I would assume that he's gonna go over David's special problems today. That's just my assumption.
Do we have robotics today?
That's up to you guys.
But I don't know that for fact.
Like, do we schedule for him?
He didn't send me anything to print
Okay.
out, so I don't.
I'll
think
be
he
there
has
if you
anything
are.
there.
I want to get the calendar from Catlin
Okay.
because I don't know, like, are we meeting this Friday? Are we not?
Will you let me know if we're meeting today when you come back? I don't understand anything we've done in chemistry this semester. I'm really nice. And like I listen, I'm pretty sure it's gonna be next week or after fall break because we're finishing up chapter 3 pretty soon, and then we have like one review day and then it's our first exam with him. So I don't even know how he tests.
Chapter 6.
Huh?
We're already on chapter 6.
Well, he has like PowerPoints for each chapter, and they all have over 100 slides.
Oh.
So we finish up part of them
issue.
every day. We were, according to the original schedule that he released at the beginning of the semester, we were supposed to take our first test like 3 weeks ago. So, and the material is just, I mean, it's easy to grasp, but it's hard to, like, I don't know how to describe this. Like naming of compounds. I understand it when I'm using a chart or something, or if you tell me these are all type 1, write out their names, I can do that. But when we have to determine what
Do you
type
guys
they
have
are,
to memorize the periodic table?
nobody said basically at the end of class we'll have it. Do you have to memorize it?
There's no
He said
way.
that he wasn't going to make us memorize it, like for an assignment or anything, because he said scientists in real life don't need it memorized. You always reference the periodic table no matter what. But he said that we were going to do so much with it, he said we'll have at least the first half memorized.
Are you guys doing anything for transition models?
Right now, at least. I don't know if we're going to do it. But he said that in the class, if you've never taken a chemistry class before, or you've never taken basic chemistry, you're set up to fail.
Oh, nice.
Which is great to hear considering I've never taken a chemistry class.
Well, we
Other
did
than the
physical
brief chemistry
science.
unit in physical science where we just balanced equations. But that's
What quiz? I don't know, I didn't check.
the chemistry quiz.
I want Catlin.
What was that?
Freaking
Did you already submit the application?
yeah. Because it said that I could as long as I got everything.
George.
Oh, he's one of
Did you
those
get it?
robotics majors.
I got stuck
And
too.
he went to state, so it's just like,
I don't know.
hey,
I did 2 wrong, but I got stuck in the same
get me
place.
in.
Isn't Catlin also does
I didn't do them
He went
on
to
paper, I did them on the
and
whiteboard.
I know he went to
And I
state.
gave up and erased everything and
I
walked
thought
out.
he went to state.
I don't think so.
Miss Turner went to state.
Oh.
Yeah. She went to their business school, so I don't know if you could judge her. She actually got a surprisingly good business school.
I
I
have
mean,
good.
I haven't really heard much about their business school, but when I was talking to someone like, you know they have a
Because
really
that's
good
where I got
business.
stuck.
I didn't even know they had a
on
business school, but
83.
okay.
They have everything.
That is so cool.
I
NC
can't
State
wait
was
to
cool.
open house. I'm gonna get lost. Are you going to
Yes, I'm
the
going.
early college session that they're having?
I don't know. I just signed up to go. I haven't really.
Yes.
done anything.
I printed it off
With like
yesterday and
intermediate
she's like,
value
I need to
theorem
like
and
plan
all that
out
other
where
stuff.
everything is so we don't get lost.
That's actually smart.
And then end up by Alex's room to pick it up.
I want to go to the sleep there.
If you were rejected by the it's just like
I'll go with you. Kind of hard to get with the fair.
I needed
My chemistry lab and my bio 2 lab both meet at the same time, which and the labs meet at the same time, I think, and
How
they
is that
meet
gonna work?
during our calculus period. Everything is
Wait,
at the
what's
same
the
time.
What aspect of it? Like if I give you, like on math, or I give you a 2-dimensional graph, we have to draw a 1-dimensional graph. Scale down straight.
Like you seem to understand everything.
So being able to interpret a 2-dimensional graph and we'll draw a graph.
And they're trying to get it to where it'll be a class
Sure what it is about it.
Davidson.
Or then the springboard starts there.
Community college also did this over in Davidson. We do. They just want this class. The professor name's Chloe and then we're getting straight to this in the class at the beginning.
oh boy.
So,
What do I want to do in my future?
my question video is only like 3 the quality has got to be poor. But, I mean, I'm fine hoping it's not happening.
My grade because of that lab dropped it by like 0.1 point. I thought it would stay the same because they were same grade. And then
Mine
This guy
dropped
just
by
grunted
0.8.
at me in the hallway.
Not even a whole point.
This guy just
But I'm
grunted
fine
at me in the
because I
hallway.
have a
Like he
whole
just
point.
walked past me and went, and I went back. Oh. So dumb.
I mean, just do for this class. I just
I mean, it
Khan
wasn't
Academy.
hard.
That's probably what I'm
I
gonna do
did it,
tonight
but
because
straight
not
down,
not
think
the
about it.
actual lab stuff.
I'm messed up. I'm getting your sequence.
What's that for? Oh, well, separate.
I mean,
I'm
gonna
just
do it.
really, really glad
don't think
that this
they're
minute
gonna
of
fit
stuff.
I did
yeah, I didn't do anything yesterday. I just played Overwatch.
It's Wednesday, right?
Yeah.
I forgot to print out the red list.
Wednesday. Okay, so do you submit it online or do you just bring it to class
Bring
there?
it to class.
Wait, what?
Yeah. Because there's
Sorry, I was looking at last one. Oh my gosh, Mr. Gatsby.
This past week, I feel so good. I
Snap.
understood what you were doing.
We're making serious progress
And that's
today.
good. Because I wasn't
He rolls
thinking,
it up. Yeah, he usually rolls it when he rolls it up. Calculus won't be the thing I'm thinking of after that. Oh my gosh. I'm looking like a scholar right now. I'm gonna get that man a cardigan. This is my bully coat. I wear this when I'm gonna take some kid's lunch money. You know, you just grab him by the collar. Yeah. Legend has it. He got help. He intentionally held himself back 2 years just so he could keep on bullying kids. I mean, that's a good answer.
What was that? Trailer park.
What?
Trailer park.
What? It was like community college. Let's get high and eat chicken tenders. That's at the
I'm
end.
just glad that we don't have to take that quiz again.
Yeah.
I mean,
That's number 10.
What'd you make?
I
90,
don't
that's
know.
number 10.
Good job.
What'd you get?
I haven't looked at it.
Mad.
You missed the quiz again.
Yeah, freaking Mason. Okay, compound has a charge of 0, right?
Yeah.
There was something else that was.
Maybe you're
It
just.
said neutral charge or something like that.
Jeez, Razor.
Is that like a
I'm not
neutral
saying anything
charge?
seriously. Chill.
Is a neutral charge not the same as charge?
It was.
Short charge.
My life feels A.
That was a. That was a 0 charge. Maybe we had different forms.
Probably. He always does that. Because
Does
we
he
sit
always
next to
do
each
that?
other and he
That's
always
amazing.
cheating.
Can I check? Your computer?
It's a guy. He's available
I've got not proposed.
So how was this?
after
And
one speaker.
Oh, you're talking about
Oh, Razor.
I have a class 2, so I can do it at 1.
It was good. If you know
Tomorrow,
what
I'm open all day after 1.
Yeah,
What's the beat?
I mean, I feel like I should be disclosing less, but it was
No,
pretty good.
you told us like too much over the Skype call, so now you gotta give us the details.
Well,
Are you
pretty
going to
good.
join us?
If you'd like,
It's a just
or I can
It might be good if you're there, if you don't mind.
I don't
You could,
You see that? That's what we call a non-differentiable point at t equals
So-
4.
one.
Because the direct
Amanda, can you
Oh, yeah, I get it.
is not
Okay.
cool.
just zoom out just a little bit, Amanda? I can't see Stanley.
Sammy, get in the shot.
Hey there, Sammy. Hey.
Hi.
Where's Dylan?
That's
what I
good.
mean.
Thank you. That's good.
The question is, where's Kyle? Where's the thing?
Razor.
Where is
You
it?
got a 100.
Where is it? Oh, cool. Well, I gotta take this and get them.
Right, so we have completed the new material yesterday for this test that's tomorrow. Today is kind of a catch-up day. Before we ask questions about, say, Newton's method, which we went over yesterday, Joe asked the question, he said, well, could we do another example where you give us a rectilinear position function in 2 dimensions, and then we have to analyze it and or sketch the 1-dimensional graph from that. Okay, so here's an example I put on the board. I don't know if Joe,
I know what I'm doing tonight, boys. Rectilinear. That's all it's gonna be.
I'll see that now. Okay, so let's analyze it. What about the intervals of advance? So 0 to 1 is advancing. looks like, so this is 1, 2, 3, 4, 5, 6. So 3 to 4. Is that the only time it's advancing? Continues all the way to 6, so we could really just make this a 6. So it's advancing. Once it makes this turn, it starts advancing the whole time. What about retreating? Someone else for retreating. Jacob says from 1 to 3, and I agree since we're going back towards the 0 position on 1 to 3. What about accelerating? Someone else.
Um, 3 to 4 is 1. I can tell you that at least.
I agree.
Right.
3 to 4 is accelerating. The other place that's accelerating.
What about 0 to 1?
Yeah.
What?
0 to 1? Is
Uh,
that accelerating?
0 to 1.
No.
No, 0 to 1 looks like it to me. I think I understand why you're saying that, but if you look at the tangent line, this velocity slope here, this tangent line slope, is steep there, and less steep there, and less steep there, and less steep. So and those represent velocities. Since my velocities are decreasing, then I wouldn't be going from big to smaller. That means I would not be accelerating.
Excellent.
But
You went
from 3 to 4, my velocity tangent lines are definitely getting bigger slopes, so that would be accelerating. Sam, you got another suggestion?
What about from 1 to 2? Wouldn't that be accelerating?
What about 1 to 3? What about 1 to 4?
1 to 2, the tangent slopes from 1 to 2, I have like a 0 slope and then slightly negative and slightly more negative. So in 1 to 2, my velocity tangent lines are still getting small. You're getting from 0 to -1 to -2. That's getting smaller. That's still not accelerating. But what about 2 to 3?
2 to 4. No.
Here you've got a negative tangent line, negative velocity, but then as you go across, it gets a little less negative, meaning it's getting bigger. Less negative is bigger. So accelerating includes 2 to 3 and 3 to 4. So we can just say 2 to 4.
Yay.
Follow that now?
Mm-hmm.
What about decelerating? Accelerate in notes. Accelerating means v is greater than 0. Actually, no, that's not true.
That's a lie.
Um,
I'm pretty
Fine.
sure that's
You're changing velocities in a positive direction. You're getting bigger. So let's write it that way. Velocity gets
V gets bigger.
What about decelerating? Velocity is going to get smaller.
Well, you could put 0 to 1 for
Smaller
that.
on the number line is to the left. So if you're negative, you get more negative. Or if you're positive, you're getting less positive. That's getting smaller. So where does that happen?
0 to 2?
4 to 6.
I don't think anything happens at 4 to 6. That's
Okay,
constant.
so once again, tangent lines here start off steep, and they're getting smaller slopes as you go along.
Yeah.
So you get to 0, and then what happens?
It goes
Slightly
negative.
negative and more negative. So all in this range here, until you get to the point where you start to turn back up, the velocity tangent lines are getting less value. They're going from big positive to small positive to 0 to negative to more negative. So that's decreasing velocity. So that's going to be
0, 2.
0, 2.
0 to 0.
Speed is getting smaller. Notice I'm talking velocity gets smaller. I'm not talking about speed. We'll get to speed in a second. That's a different issue. Involves slowing down and speeding up. It doesn't take into account velocity. Velocity takes into account speed and direction of the speed. Okay, so now we'll do speed up. Don't think there.
Well, that's if acceleration times velocity is greater than 0.
Yes. So to have speed up, you got to have acceleration times velocity greater than 0, which means they have to be going in the same direction.
So do you want to make that number line again?
Velocity. Pardon me?
Are you going to make that number line again that shows the regions where the thingies are positive and negative?
Do that, or I can just do it right here. Okay, so where are my, let's see, advancing and retreating. That would be when velocity is positive and negative. So this is velocity is greater than 0. This is velocity less than. So if we mark those, we said 0 to 1 is a positive in here. And then 3 to 6, so from here, that's my velocity. What about acceleration? Accelerating means positive acceleration. So from 2 to 4. Oh, I didn't mark by retreating. I'm sorry. Retreating would be a negative here. So now we'll do acceleration. For accelerating, it's positive acceleration. If it's decelerating, it's negative acceleration. What about out here on this, out there on that end? Now we never said anything about out here for acceleration.
It's going to be a single value because it's a
What value is the acceleration going to be?
For the V, right?
0. How do you know the acceleration is 0? Because we're constantly changing our position at the same rate. That means velocity is constant. And since velocity is not changing, that means acceleration is 0. Okay, so now if we multiply these together, we can get our speed up distance. Where do we see speed up now? That has to be, as Razor said, the product of, we're looking for speeding up. We want the acceleration and velocity to be working together, both going in the same direction. So either both positive or both negative. So where does that happen?
1 to 2.
2. Anywhere else?
3 to 4.
3 to 4.
Got it.
And slowing down. We want to slow down. You got to have a velocity. Then your acceleration has to work against you to slow your motion down. Whichever way you're moving, acceleration is going the opposite. Slow it down.
Well, 0 to 1.
2 to 3. That's it.
Nice. Is it time to get
Oh.
rectilinear?
If we were to describe this in words, let's describe it in words. So,
Okay.
0 to 1, I'm moving forward, but I'm slowing down the whole time. Because my acceleration is opposite to my velocity. When I get to time 1, I come to a momentary pause, and then I start moving backwards, which means my acceleration is still negative and has drawn me, made me pick up speed. So speeding up here, going backwards. But then, right at 2, I'm still moving backwards. But what happens? Still moving backwards when I get to time 2. But my acceleration turns the other direction and works against my velocity. My acceleration is now the opposite of my velocity, which means I start to slow down until I come to a pause again. And then, from 3 to 4, I'm accelerating and moving forward. At 4, I kind of turn off, I take my foot off the accelerator, and I just kind of coast at a constant velocity for the last 2 seconds. I'll see this. That's how you might describe it in words, like on a test model. What else do you have to be able to do? Draw a one-dimensional graph of this.
Let's get rectilinear. Wait a second. I don't think 5 is after 6.
That's an S.
It's an S?
Isn't that to show the position?
Yes, that's an S.
Is that an S?
That's an S.
Oh, yeah, is this an S? Yeah, that's S for,
Okay.
this is an S scale, not a time scale. This axis I'm drawing here.
All right.
So that's an S.
Yeah.
Okay, so where do I start my one-dimensional position function?
At 1.
Time 0, I'm at what position?
1.
Making me second guess myself.
Which way do I go from there?
Let's go right.
Where do I stop when I'm going right?
Stop at 3.
3. So what time is that?
T equals 1, 2, 2,
No,
1.
you're right, you're right. 1 is right, you're right. Then what?
You go up a little, which makes no sense, but you know, I'll take it. You go back to 2. And that's T equals 2.
What?
And then,
Forward to 4.
wait
And
a
then
second.
something changes, but I still move forward until I get to 5.
I think
This
I
is
might-
T equals 6, and at T equals 4, something changed.
What's the position graph?
I think I did something wrong here.
That's not right, folks.
I think T equals 2 is supposed to be T equals 3.
This is supposed to be T equals 3, right? So you led me astray.
Well, I was second guessing myself too, so.
Something happened between T equals 1 and T equals 3. So I want to put I need a bigger graph. I should have made a bigger graph. So I'm going to have to go make this bigger so y'all can see this. Let's go make it bigger over here. I apologize. Let's start over. There's S. 0, 1, 2, started here at time equals 0. We moved over to position 3. That was time equals 1. Then we move back to position 2. Back to position 2. At time equals 3. But something happened right there at time equals 2. And from time 3 to time 6, we move forward, position 5, and we stop. But something happened at time 4, position 4, so right there. Time 2 happened at about position 2.5. Time. So now we got to go in and put in our arrows to indicate what's happening. I'll keep my same colors. Red is velocity, green is acceleration. So, question? Yeah. Yeah, I guess that should be right. Thank you. That should be right there is time.
Ooh.
Right. Maybe get my position must go. Oh, only there is not right. Okay, so on the first leg of this walk, what do we got for in terms of velocity? Okay, well, that way, so my velocity arrow is pointing right. Now on the second leg, my velocity arrow is pointing left there, and it continues to point left in the second part after 2.
You're about to get some acceleration changes, though.
Yeah, that's where my acceleration changes. That's right. Once I start back this way, my velocity arrow is pointing right. Even after something changes, it's still pointing right. So each leg of the walk, the velocity arrow is not changing. But I have to indicate what's happening in each piece of the puzzle. So from t equals 0 to t equals 1, which way is the acceleration arrow pointing?
Deceleration. So,
slowing down, that means my acceleration arrow had to be pointing
left.
Opposite direction. Slow me down. Once you come to a pause at time 1 and you start backing up, the reason you start gaining velocity going backwards is your acceleration arrow initially is still pointing the same direction. So my acceleration arrow after time 1 but before time 2 is still pointing left. Caused me to go faster in a backwards direction. But then at time 2, something happens. My curvature, instead of curving down, which makes me have a deceleration, my curvature starts up, which makes me have an acceleration instead of deceleration. So I'm now changing my acceleration direction the opposite way, which is now going to act against that velocity to slow me down, make me stop right here at time 3. Once I finish my little pause, my acceleration arrow is helping that velocity to get faster. I'm going faster. But then after time 4, I don't have any acceleration, so I'm not even going to put an arrow on.
Okay. Is there any way to indicate that the velocity just remains constant?
The only way I can indicate that is by not putting, I guess instead of putting instead of putting acceleration arrow, I could put, if you like, I could put a 0 there like that. I was just going to leave it off, but if you want to put a 0 to more precisely indicate that the acceleration is 0 and it's not affecting the velocity, just maintain your constant velocity. Maybe that's a better way to show it.
Could I just draw an arrow to that portion of the rectilinear graph and say there is no acceleration here?
Yeah, or you could just, that might be getting clearer. Well, because again, if you only have one color, that's the reason I suggested, if you only have one color, that's the reason I suggested using a single arrow for velocity and double arrow for acceleration. Plus, it kind of makes sense because velocity is first derivative, and acceleration is second derivative.
Mm-hmm.
But since there is no acceleration, maybe it would be easier if you only have one color, as Hazel said, just to say
You can use a different symbol.
acceleration equals 0. That's the plus. Some might be easier than to try to draw a circle on there or something else. That's more precise. That's a good suggestion. We have all this now? There's one good example. So yes, you need to be able to do that on the test. Given a graph, you will interpret. Given a function, algebraically, you need to be able to do the algebra of interpreting it as well. So you got to be able to do both. Other questions you want to go over? Want me to do this method done?
Mr. Gaddis,
Yes, President.
this is the block 4 test, right?
I guess what block are we in now? I don't have my syllabus on it.
So what's
I
the
think it
first?
I think, yes, it is block 4. You're right, block 4.
What's the first section that it's gonna cover?
We're going to cover two sections, 2.1 and 2.2.
Okay. Just making sure.
Those were two very important sections.
Mm-hmm.
They're laying the very foundation of our calculus for the rest of the semester. So these are two very important sections. These we've spent more time on just two sections than we have on maybe other sections before. And our pace will probably pick up afterwards. That's okay.
On the graph from t equals 1 to t equals 3, what are the acceleration arrows doing? Because it looks like I see 2 arrows pointing in the same direction.
From t equals 1 to t equals 3. Yes. Can you zoom in here for us, Joe? I mean, pretty tight, right in here. Is that as far as it zooms?
Keep on going. Keep on going.
More.
Are they pointing in the direction?
No.
See that better now, Sammy?
Yeah. Why do we have 2 arrows when it's accelerating instead of just 1?
You can hear why there's an acceleration arrow here and an acceleration arrow here. Is that what you're asking?
Yeah.
Okay. Because I'll go back to that picture if you that's when we need 2 cameras. You know, we need a real setup of a professional TV production. Because initially at time 1, we've come to a pause at time on the picture. At time 1, we came to a pause, and we were going forward. So look at the picture. At time 1, you came to a pause. You were going forward, and then it said we're going to start going backwards. So I came to a pause, and my velocity now changes from going forward. I had been going forward. Now my velocity after time 1 is going backwards. Well, the reason, if you're at 0, if I'm not moving, the only way you get moving is if you add some acceleration to cause that velocity to increase. So I added some acceleration in a backwards direction to cause my velocity to start going backwards. But at time 2, and I'll go back to the picture in a minute, what happened was I like saw ahead. Oh, look, I'm looking in my rearview mirror, and there's some kid running out behind me after the ball. I got to hit the brakes so I come to a stop and not hit that kid. Well, so my velocity is still going backwards, but I hit my brakes, which causes an opposite acceleration. Instead of continuing to go faster backwards, I'm now slowing my backward speed down so I can come to a stop and not hit the kid. So that meant my acceleration is the opposite direction of my velocity. So if you're moving backwards and you hit your brakes and you're actually accelerating forward, it seems counterintuitive, but that's the truth. because acceleration is the change in velocity. And if I'm increasing my velocity from a -10 to a -8, so I'm going backwards at -8, and I hit my brakes, that means I've increased my velocity from -8 to -10 up to -8. That's an increase. So if I've increased my velocity from -10 to -8, then I've had a positive acceleration. I know that feels counterintuitive, but that's how the numbers work. So back over here on the original picture, why I have that one more time over here. So on this original picture, once again, our velocities are positive, but they are getting less positive as I go along this curve. That means my velocity is decreasing. It's getting from big positive to small positive. It's decreasing. That's why I have what's called negative acceleration in here, up to that peak. Now, after that peak, my velocity arrow, my tangent line slope has a 0 slope, then it's slightly negative, so it has continued to decrease. It went from 0, it's decreasing to -1, decreasing to -2, decreasing to -3. So my velocity continues to decrease up until I get to time 2. That whole time, because my velocity is decreasing from positive to less positive to 0 to negative to more negative, that whole time my velocity number is getting smaller. That means I've got negative acceleration, deceleration we call it. But when I get to time 2, something changes. Now my velocity tangent line quits getting less negative and starts pulling back up. So now it's, instead of -8, now it's -3, and then it's -1, and then it's 0. So in that frame between 2 and 3, my tangent lines are getting bigger. The slope of my tangent lines are getting bigger. They're going from negative, big number, like -5, up to a smaller, up to a bigger number like -1, up to a bigger number like 0. So in the frame where I'm getting bigger velocity numbers, I have acceleration, positive acceleration. So then 1 to 2 and 2 to 3, something is different in what's happening. My acceleration was negative in 1 to 2 because my velocity vector kept getting more steeply negative, but then it got less steeply negative, so my acceleration is telling me I'm doing positive. That's why over there I have two different, in the time frame from 1 to 3, I have two different pointing acceleration arrows, because in that interval from 1 to 3, my acceleration actually changed. Did that answer your question, Sam?
Yes. Yes.
I can't.
Yes.
Yes. Okay. I couldn't hear you, so I was like, is that a I don't want to answer because I don't know, or is that yes, I got it, or no, I have no idea what you're talking about? Okay. Any other questions on that?
I already did.
Right, but questions anyone else, Greg?
Yeah. But you can just give us a comment.
All right.
Are you going to give us a formula?
The question over here was, am I going to give you the derivative definition formula? And the answer is no, you need to know that. In fact, you'll need to be able to state it and explain it on the test as well as use it. One of the questions that we discussed yesterday was, tell me what the definition of derivative is, which is limit h approaches 0 of, that's the definition of derivative function. Explaining it, like we talked yesterday, calls slope of secant lines approaching slope of the tangent line and that kind of thing. That's what we talked about. That's So yeah, you need to know that and be able to not only use it, but explain it. Okay, then the question was, can we do this game over here, but do it algebraically? Okay, sure. So, I don't know. Making something up. I hope it works. I guess the first thing we have to do, if we're going to fully analyze it, the velocity function. How do we find the velocity function?
Well, yeah. You take the derivative of it. Equals lim h approaches 0. Does he want me to say it? Okay, he's gonna just do it himself.
Okay, so what do we got? Q plus H plus all I'm doing is it's just doing out the algebra here. Hopefully you know how to do that by now. I shouldn't have to be reminding you that. You just need to know the definition, and then it's just a matter of doing the algebra. And now the indeterminacy is gone by factoring out an h. I cancel that indeterminacy, so I can now apply the continuity theorem. That gives me 3t squared plus 3t times 0 plus 0 squared plus 1, which is 3t squared plus 1. So there's my I made it a problem that's not going to be very helpful to us because and we can finish it. Does anybody see a problem with the answer I have is correct, but does anybody see a problem with the result? I mean, I'm already thinking ahead. Why did I find the velocity function? Let's review that. Why did I find the velocity function? this algebra, or are we still sketchy on the algebra side of it? So once you know the definition, it's a matter of just plugging into the function. When out, what that means, expand out your binomials and stuff. Combining like terms, those are algebraic vocabulary words. Cancel common factors, and then apply the continuity theorem of limits. So I get down to this function here, that's my velocity function. One more time, why did I find the velocity function other than I said do it? Why do we need it? It gives you tangent lines, and why is that important to us in analyzing this function? Yeah, it tells me when my velocity is positive, negative, and zero. So it's telling me my, when I'm moving forward, when I'm moving backwards, when I'm pausing. So that function is important to me. It tells me all that information. Velocity positive, moving forward. Velocity negative, moving backward. Velocity zero, I pause momentarily. So with that in mind, my brain's already kind of spinning ahead because, well, I got to make up a problem that we can try out. So what do you observe about this? It's never negative. It's never even zero. It's always positive. So what does that mean?
You're not
Oh,
going
it's moving forward. Okay, so this example is perfectly legitimate. We did our algebra correct. We got the correct velocity function, but it's kind of a little bit boring. So I'm going to change it a little bit. I'm going to go back here and put a minus right there. That's going to put a minus there, and a minus there, and that's going to put there and there, and a plus there, and that's going to put minus there, and that's going to put a minus there, and a minus there. So now I have something that yields zeros. Well, if I go over this board, I can say, when is b equals 0? Because all I did was change one sign. It just goes all the way down. It comes out right there. I'm going to set the velocity equal to 0. That means I got 3t squared minus 1 equals 0. So t equals plus minus square root of 1/3. Okay. What is that?
Are those like the
first
vertex
order
points, the max/min thingies, where the tangent line's
Back
going to be?
there, you got, that's exactly right. In terms of the motion, that's what I'm causing. That's right. You got max mins there. You're absolutely right. On the two-dimensional graph, you'll see max mins when you pause. Go over there. That's where you'll have pauses here. Okay, so I can't use both these because why?
Why?
The domain is 0 to 4. Okay, so this tells me I can now decide some stuff here about this. I need to know left and right of that number, but only within 0 to 4. So when is velocity greater than 0, and when is velocity less than 0? And this would be called advancing, and this would be called retreating. So I got to look at my velocity function and decide when it's positive and when it's negative. Well, it changes at -1 square root of 1/3. From positive to negative, I put it 0. Any ideas?
What is he saying?
-1/3. Well, yes, but we're only dealing with that. Oh, no, okay. So it's retreating. Start again.
So it's retreat negative 2. Or you can do it. That's all that's okay. So it's advanced.
Now start with the retreat. You're right.
Retreat. Zero to 1/3.
That's right. Good.
And it's advanced. 1/3.
4. Thank you. The overall function graph, if I drew a graph on the top and looked at all of the whole domain, you're right, what you're saying. But I'm only looking at ethanol, so there we go. Okay. So I know when it's advancing and retreating. What about acceleration? How do I find acceleration function?
Do it again.
A of t, sigma 2, and then h goes to 0 of v of t plus h minus v. Acceleration is the derivative of velocity. It's also called the second derivative of position. So this is the limit. H goes to 0. 1. It's squared minus 1. So 3 times t plus h squared minus 1 minus h squared minus 1. H goes to 0. 3 squared plus 16h plus 2h minus 1.
Can you move in a little closer, please? To the board.
You should be able to do this yourself. I suggest you do it yourself, and we'll compare notes at the end. You're not going to, I'll be able to do your algebra fairly quickly yourself, I think, by now. 0. I've got h, so it's h over h. Determinacy is gone, so I can apply the continuity theorem. So this is 6t plus 3 times 0, which is 6. So my acceleration function is 6t. Based on that, we should be able to determine when is it accelerating and when is it decelerating. When is it equal to 0, so we can determine that. So
Equals 0.
A of t equals 0, you've got 6t equals 0, so t. So it changes its acceleration at time 0. So it's accelerating. A is greater than 0. And decelerating, A is less than 0. So when is it accelerating and when is it decelerating?
It's always accelerating.
You want to say 0 to 4 for
0 to
acceleration?
4.
Yes, all the deceleration is left at 0, but we're not including that in our domain. That's correct. So we now have our intervals of advancing, retreating, accelerating, decelerating. The last thing is intervals of speed up and slow down. So that's when we made a number line from 0 to 4. And we put all of these critical values on here. Recall that we call this, these are my first order critical. And this number is my second. When we located all of our critical numbers on here, the only one we have is square root of 1/3. And like they did over there, I'll even match my color as well. So I'm back to green here. Okay, so my velocity from 0 to square root of 1/3 is negative, positive after that. And my acceleration is always positive. So from that, you can determine speed up and slow down. When do we slow down? Okay, and the final puzzle piece is to draw a picture of all that in one dimension, like we've done up here.
Like the rectilinear?
Right? Okay. So at time 0, what position did we start at?
-1.
At time 0, that's our starting time. What position did we start at?
It's -1.
-1. So I'm starting at position -1 at time equals 0. Then we move forward. Wait. No, that's not true. We're going backwards, so I should put my time 0 on this side. Then we go backwards for a little while until we hit time equals square root of 1/3. Then we go forward the rest of the time until we hit time equals 4. Using your calculator, what position, so this is position -1, what position do I hit when I'm at square root of 1/3? What position do I hit when I get to time 4? I can do that one. That's 64 minus 5 is 59. That's 59.
59.
Square root of 1/3 will let you do that. Give me a decimal every time. 1.49.
Yeah.
Okay, so those are my positions, my key positions that I've observed. All I have to do is put in the arrows of velocity acceleration on here. So started this going that way, so clearly velocity arrow is that way, and then it went back that way, so velocity is that way. That was easy. And now acceleration. What did we decide about acceleration? Acceleration is
All the time?
always positive.
Yeah.
So acceleration is opposite of my velocity initially, which is what makes it come to a stop. If you don't have it, Newton's laws of motion. If you're in motion and you don't do anything to it, you're going to continue in that same motion. If I'm moving and I want to come to a stop, I have to operate on it somehow. And so if I'm moving left, then I've got to do some kind of force to it the other way to make it stop. And then I just, my acceleration goes this way the whole time, so I'm just going to keep speeding up as I go forward. On that?
Yeah.
Raise up. You were up, your hand up first, this hand. Go ahead.
On the tester, you're gonna tell us what we're supposed to be looking for with like advancing, retreating, speeding up, slowing down, or are you just gonna tell us to analyze this function?
That's a good question. Answer's yes. Meaning sometimes I'll say, hey, just find the intervals of speeding up and slowing down. That's all you gotta do. I also might say, here's a function fully analyzed.
Okay.
You have both different problems. Typically we'll try, we'll also, along those lines, test parts of it in different problems to see, well, do you know what you're doing when you're dealing with finding a drift? Can you find a drift? You know how to analyze the first order circuit, that kind of thing. So usually there's some pieces like that, but then there might be something where you just do the whole thing. Yes.
We have the accelerating sonic system. So it'll take from time 0 to 1/3. I guess if we're slowing down, so we accelerate. Okay.
Yeah. The question is, this is back to the same question. So one more time. I'm accelerating. My acceleration arrow is pointing right, so I'm accelerating, positive acceleration, the entire time. However, if we talk speed, my speed, because my acceleration is the opposite of my velocity, my speed going backwards is slowing down. And then I hit a pause, and because these are working together, acceleration is actually increasing my velocity. Then I'm going to be speeding up. Okay? The same idea with throwing a projectile into the air. If you throw a projectile into the air, it does that, right? We all agree that that's what it does? You also agree that on this time interval here, if I was to draw a one-dimensional map, what do you observe? Well, it starts at some position, it goes forward a ways until you get to, we'll call that C. This is C. So that's time equals C. It pauses, and it comes back. Actually goes all the way back to 0. Velocity is forward at first, and velocity is backwards second. But the whole time, the entire time that projectile.
I think Sammy had ready.
Yeah. Well, yes, Sammy, I'll come right back to you. Thank you. The whole time that projectile is in the air, which way is the acceleration acting? It's pulling that thing down. The reason you throw that rock up in the air and it doesn't just keep going all the way to the moon is because gravity is making it stop. And the reason it comes back down Just because gravity makes it accelerate, it gets faster and faster as it's coming down. So the whole time, my acceleration arrow is pointing left, which is going to cause this to slow down, stop, and then speed back up as it comes back down. Same idea as up here. I don't know if that answered your question. Sammy, you had a question a moment ago, and I got to with another question, so I apologize. What's your question?
When we were solving for the velocity equation, you went back and changed the signs of it for some reason, and I didn't understand completely why we went back and changed it, because we originally got 3t squared plus 1.
Okay, 3t squared plus 1 was the original function, you're correct, and that was because this originally was t cubed plus t minus 1. So these two go together. This and this go together. The question is, why did I change it? Well, thinking ahead, when I got to here, and I'm thinking ahead, the reason that I wanted to even find the velocity function was in order to find the first order critical values. Meaning, I wanted to find when the velocity is 0. Well, if you set this equal to 0, if you set v of t equal to 0 like we did over there, you get 3t squared plus 1 equals 0. So then you get t equals plus or minus the square root of negative 1/3. Because you have to subtract the 1. But now that's imaginary, so we won't deal with that. So that's why I said, oops. I accidentally created a function that has imaginary roots on the velocity function, and so I went back and changed my original function so the velocity function would have real roots. Does that make sense why I did that now?
Yes.
Okay. 4 minutes. That doesn't leave a whole lot of time.
You get to talk about Newton.
What's on the test again? Just a quick review since we've done this now. You're going to have, I'll give you a graph or 2, 3, and you have to tell me about it. So given a position function graphically, tell me about it. Analyze it. And some of it will, a lot of it will just be find these bits and pieces rather than just completely analyze. Given a position function as an equation, analyze it, algebraic it. So find the velocity function using derivatives. Find the acceleration function using derivatives. What we just did. And then find the critical values, and then find intervals of accelerating and decelerating, all that kind of stuff like we just did. That's the main thrust of the test. You also have to be able to define, state definition, explain derivative. Okay. Emphasis on explain. I'm assuming you're going to have to know it. I'm telling you, you have to know the derivative definition because you're going to have to calculate the derivative. So if you don't know the definition, you can't calculate it. But then I also want you to really explain what it means in terms of instantaneous rate of change, average rate of change, slopes, tangent slopes. Those all go together, you realize, right? What's the correlation? The slope correlates with which velocity? Average or instantaneous? Average velocity, secant slope. Tangent slope correlates with instantaneous rate of change, instantaneous velocity. Okay, and then you'll also have a Newton's method type of problem.
Yeah.
Can we do one of those?
3 minutes.
Not really a lot of breadth of knowledge, but content, but it's certainly a lot of depth in my mind. Okay? Other question? Raise his hand up. I'm sorry. Thank you for pointing that razor. Yes.
Can I at least ask, we did a Newton question yesterday, right?
Yes.
We just kept on getting close to the root. When will I know when I'm finished with the Newtonian method thingy?
Okay, that's a good question. Let me look at what their directions are, and then I'll answer the question in a more generic answer in just a moment. Their directions are they don't give you a cut. You're right. They don't give you a cutoff. Okay. So how do we normally do this in real life? On the test, I will just tell you how many iterations to do. You know what I mean by that? I can start it off. Here's our first iteration. Let's just guess this number. And then we did an iteration and we found the tangent line and we found the intercept of the tangent line. And we did it again. I'll tell you how many of those iterations to do. In real life, and the way your calculator works is you have a cutoff based on accuracy. Mm-hmm. So your calculator employs Newton's method or something similar. And instead of saying, well, I'm only going to do this 5 iterations and just randomly stop at 5, it doesn't do that. It has a check mechanism. And so remember how we were writing the list of approximations x1 and then x2 and x3? Well, the check, the cutoff is you compare each pair as you go down the list. When the difference between any 2 pairs, consecutive pairs, as you go down the list, when that difference becomes small enough, whatever we decide is small enough, then we say we're there. Like on your calculator, what it might say is that when your difference between 2 consecutive approximations, when the difference between those 2 numbers is less than 0.000000001, when that difference is that small, then we're close enough, we'll call it good. The calculator quits. Otherwise, it's going to run forever. If I was doing it manually, like back in the old days, we didn't have that quite a bit of accuracy, but with your calculator, you can do it easily. So the way you know to stop is based on what's the tolerance level we're accepting for our approximation. Does that make sense?
Yeah.
On the test, it could be, and if you go to differential equations eventually, we'll define our cutoff not on number of iterations, but on accuracy, like I just described. For here, I'll just tell you how many iterations to do and you can go. Okay. So if you can do what we did yesterday on Newton's method, you'll be fine. Other questions? Okay, so we will start early here. Y'all will start on time and stay a little late. So we'll see you tomorrow.
Well, there's only 2 sections, so we're probably going to reread them. And then we're going to also with the Newtonian part. And then we'll be good.
Yeah, I can do those.
I have a feeling there's going to be a lot
really
of
well,
writing,
but I just
like verbal writing.
I keep getting stuck on the derivative one because I don't know.
But never touch it.
That's what it is.
So then my question is, how would it know whether a root is
Did I use the first derivative?
versus like?
Because you can just find the actual root itself.
No, you're always in your calculator, you're solving for the root, and you get 10. That means it just got close to 10. So what if you were solving for a root and got like 9.99999?
Yeah.
How would it know if that was 9.999 repeating or 10?
that's the same. Yeah, I know.
So you're always getting the first one.
He'd give you credit for that circle.
Yeah, but then it has to like plug in values for when the tangent line is at this point. I don't know if they're talking about that point on the original function or
Whatever.
yeah.
How do you pick the first value? Do you just choose a random value in the interval?
I thought you
Yeah.
just picked. I thought you picked one of the zeros.
I just,
Not a billion zeros, but one of the points that it gave you. Like
yeah, like it gives you an interval. You just pick
yeah,
one
you
of the
picked one
random
of the.
ones.
I think you can, because it's just, you find a tangent line and work it out.
That's like,
And then you have to keep changing the point on the line so that you can get closer and closer. seen it except for Newton's method. Like
yeah.
No, I just did
Instead of a formula, that would be great.
What was the trick?
I could be wrong, but I feel like this class is not only helping me counting smart, but it's making me do math so much faster. Which is helpful on standardized
For the
tests.
math competition, big time.
But the time limit of test is 65 minutes, and the tests are longer than any other test in any other course, and I gotta do it faster. And it's crazy. But I'm actually,
You're doing much better than when you started, though.
yeah, I am doing a lot.
Isn't it getting a little easier?
Yeah, just my algebra is not that great from high
Yeah,
school.
you really should have gone into 171.
Yeah, that's what I told Mr. Cat. I don't suggest anyone skip 171.
Yeah, you would have known how to do all of this stuff, and you would have seen a lot of these formulas before.
Yeah, I think I'm good as long as I can finish it.
I think Dylan would have been good too, but he's slacker. Will you ask him? Will you see him?